This is Euclid Book 10, proposition number 96, and this is the last time we'll be using this particular diagram right here. It says, if an area be contained by a rational straight line and a sixth apotome, the side of the area is a straight line which produces with a medial area and a medial hole. For let the area AB be contained by the rational straight line AC. Okay, well this is area AB and it's being contained by this. And the sixth apotome, which is this. This is the sixth apotome right over here. I say that the side of the area AB is a straight line which produces with a medial area a medial hole. For let DG be annexed, okay, for let DG be the, I'm going to say it real slowly. For let DG be the annex to AD. This is the annex to that. Therefore, AG and GD. Now, what is AG? That's this whole line right across here. What is GD? That's this whole line right across here. They are both rational straight lines, and they are only commensurable if you square them. Okay? So these two here are squares of those two lines I just showed you. Okay? So these are commensurable, but the lines themselves are not. Neither of them is commensurable in length with the rational straight line AC set out. Okay, so AG is not commensurable with this, and neither is DG. DG is not commensurable with this. And the square on the whole AG is greater than the square, okay. And the square on the whole AG, which is this one right here, is greater than the square on the annex DG, which is this one right here, by the square on a straight line incommensurable in length with AG. This is by Euclid Book 10, third set of definitions, number 6. Since then, the square on AG is greater than the square on GD by the square on a straight line incommensurable in length with AG, therefore, if there be applied to AG a parallelogram equal to the fourth part of the square on DG and deficient by a square figure, it will divide it into incommensurable parts. That's by Euclid Book 10, proposition number 18. Let then DG be bisected at E. We're bisecting this whole line here, right here. Let there be applied to AG, okay, we're going to apply to line AG, a parallelogram equal to the square on EG and deficient by a square figure, and let that be rectangle AF and FG. Now, do you guys know how we got rectangle AF and FG? Well, here's how that one worked. Two sides of that rectangle will be length of AF, and two sides of that rectangle are going to be length of FG. That's how we got it. So, the area in this rectangle is going to be the same area as in this square. Okay. Therefore, AF is incommensurable in length with FG. This line here is not commensurable with this. But as AF is to FG, as this line is to this line, so is AI to FK. What is AI? That's this plus this plus this. This whole area here is to this little area right here as this line is to that line. And that's by Euclid Book 6, proposition number 1. Therefore, AI is incommensurable with FK. So now we're going to say that this plus this plus this whole area across here, is incommensurable with this little area right here. And that's by Euclid Book 10, proposition number 11. And since AG and AC are rational straight lines commensurable in square only, so the only time that AG and AC are commensurable is when you square them, AK is medial. So this plus this plus this plus this whole area is the medial area. That's by Euclid Book 10, proposition number 21. Again, since AC and DG, what is AC? That's this right across here. What is DG? That's this right across here. Are rational straight lines and incommensurable in length. Okay, so this is a rational straight line, so is this, but this is incommensurable with this. DK is also medial. Okay, what is DK? That's this plus this plus this. All this area across here is medial. And we know this because of Euclid Book 10, proposition number 21. Now since AG and GD are commensurable in square only, so AG is this whole line right here, and GD is this line right across here, and they're only commensurable if you square them. Therefore, AG is incommensurable in length with GD. This line is incommensurable with this. But as AG is to GD, now we're going to start a ratio. First two parts of that ratio is, as AG is to GD, so is AK to KD. What's AK? That's this, 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 and this. All this area, as this whole thing is to KD. What's KD? That's this, this, and this. Okay? So the whole area to the three parts. Okay. That's by Euclid Book 10, proposition number 11. Now let the square LM be constructed equal to AI. Okay, so this whole area right here, from here, 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 and here, the whole area right here, that is equal to the area of this plus this plus this. And let NO equal to FK. Okay, this area right here is the same as this little tiny area right here. And they are about the same angle, be subtracted. Therefore the squares LM and NO are about the same diameter, which is by Euclid Book 6, proposition number 26. Okay? So, this square here and this tiny square here are on the same diameter. Let PR be their diameter. That's this. And let the figure be drawn, which we did. Then in the manner similar to the above, we can prove that LN is the side of the area AB. So now we're going to prove that this is this. I say that LN is a straight line which produces with a medial area a medial hole. For since AK was proved medial and is equal to the squares on LP and PN, okay, what is AK? That is this plus this plus this plus this. All of this. Okay? That whole area is medial. And it's the same amount of area as if you were to take these two squares and add their areas together. In other words, you add this area to this area, you get this whole thing. Okay. Therefore, the sum of the squares on LPPN is also medial. So if you add these two areas together, you get a medial area. Again, since DK was proved medial and is equal to twice the rectangle LPPN. Okay. So, DK, what is DK? That's this, this, and this. All of this is medial. And if you multiply this area by 2, you get this, this, and this. That means that if you multiply this area times 2, you'll get a medial area. And since AK was proved incommensurable with DK, so we now know that this plus this plus this plus this is incommensurable with just this, this, and this. The squares on LP and PN, that's these two right here, are also incommensurable with twice the rectangle LPPN. So, if you add this area and this area together, it's going to be incommensurable with twice of this. And since AI is incommensurable with FK, since this, this, and this is incommensurable with that, therefore the square on LP is also incommensurable with the square on PN. This is incommensurable with that. Therefore, LP and PN, adding these two areas together. Okay, hold it. Not okay. Let's back up again. Now we're going to talk about line LP and line PN. Line LP and line PN, they are straight lines. They are incommensurable in square, okay, which makes the sum of the squares on the medial twice the rectangle contained by the medial, and further the squares on them incommensurable twice the rectangle contained by them. Therefore, Ln is the irrational straight line called that which produces with a medial area a medial whole, which is by Euclid Book 10, proposition number 78. And it is on the side of the area AB. Therefore, the side of the area is a straight line which produces with a medial area and a medial whole. Wow, what a proof. And I bet you're glad this one's over with. You will never have to see this particular diagram again. We will have another diagram, alright? And this part you'll see again, but you won't see any of this anymore. I bet you're glad for that. Alright, I will tell you more in a future video, so I want you to stay tuned. Oops.